Good afternoon, everyone, and welcome to Fridays with Keenan's Cutting Edge. My name is Jenna Labor, and I will be your host as we continue to explore the dynamic world of Don Keenan's trial philosophy, The Cutting Edge. Those of you joining us live this afternoon have the opportunity to ask questions and interact with our speakers. So if you would like to do that, please place questions, comments, or anything you'd like to discuss with our speakers in the comment section below, and we'll be sure to address those. Episodes are released each week following the live broadcast, so be sure to hit that subscribe button and the alerts icon to make sure you don't miss an episode. Today, we have Monte Tynes with us to talk about product liability cases. And he brought with him a couple of professors from Mississippi State in mechanical engineering. So Monte practices personal injury law in Mississippi. And as always, we will put his contact information in the description below so that you can reach out to him about this particular topic or anything edge. Monte, please introduce your guests and enlighten us with your expertise on products liability cases.
Thank you for the introduction. I don't know how much expertise I have, but I did bring two people with me that have an immense amount of expertise in the field of product design, Dr. Will Whittington and Professor Ross Smith. They teach mechanical engineering at Mississippi State, and we worked on a couple of cases together. And what I hope to do today is kind of let them talk about the design process. And I'm going to pipe in of how that fits in the prosecution of a products liability case and how that fits in with the general elements that we need to prove our case and the evidence that we need to go get to prove our case. So, and we're going to do a little, for those that are watching, with YouTube, we have a little PowerPoint presentation that's got some slides, and Professor Smith is going to go through those slides. So whenever y'all are ready, I'm ready.
All right, take it away.
Dr. Whittington, we first met on a case that we had where we were suing a manufacturer of a trampoline contraption at a trampoline park. We sued the manufacturer of that called Fun Spot Manufacturing. And I, during that prosecution, and when we met, I had the pleasure of having you and Ross Smith work with me on that. And I've always thought as products liability cases is you're trying to kind of play MacGyver and trying to figure out what happened. So good afternoon, and why don't you introduce yourself a little further, you and Professor Smith.
Hey everybody, so I'm Will Whittington. I teach at Mississippi State. My background is in the design of machines, so in mechanical engineering. We teach students how to apply engineering in a design field. Background is in research for design of products in many different aspects. We do this kind of work as a service, and I met with Monte, and we uncovered some really interesting things, and I think we can share that. Ross, I think you're driving that PowerPoint, so you can go on.
Before we get into it, you said something that was really, really interesting. You said you think of this as a service. If you could, tell us a little bit more what you mean by that. You think of this. You're talking about the work that you do with lawyers and
That's right. That's right. So we're on the front end of the problem. Normally, what we're doing in our day job is before there's even a product. We're teaching the next generation of engineers how to think about design, how to include the aspects of design that are critical to the business that they may exist in, whether they're an employee in a business, whether they become a business owner. In either case, they're going to be developing and delivering a engineering product or a service in engineering. And in either case, there's many things to think about. There's cost, there is the market, there's also the performance. And in the performance, you think about the safety, risk, and there's a lot of variables that are illustrated in front of you. And but that's where we reside at the beginning. And so it's a service really to come in on the back end when a product is already in the stream of commerce and it has been used, and there are these issues that cause damage or injury, and then we help people like Monte look at that from the engineering perspective and say, okay, well, what was missing in the area of mechanical engineering that should have been caught in the design process, should have been caught in the manufacturing or in the distribution, the use, and throughout the entire life cycle of the product.
And when you're starting out the design process, when you figure out what you just have an idea, you want to put something in the stream of commerce, what's the first thing that you think about?
So the first thing that people typically think over here on the left is, and this is kind of a simplified version, is maybe there's some customers, whether it's a business or people that have a need, and then someone from a business, a marketing team could be the owner, depending on the size of the company, receives that information and says, aha, we need to solve this problem. That then gets pitched to engineering design. Designer is someone in the company who is qualified to do some sort of engineering design, depending on the field. And they're looking at that opportunity and saying, okay, well, what can we make? And that's where the design process happens. Then that gets pitched over to production, who then makes the product and sells it. That's typically a simplified version of how that could work. Rarely does that happen. What usually happens is more to the right, where it's this iterative process between targets from the business, from the market and sales, constraints in production, and the information that the product designers and engineers have to do that. So that kind of iterates through those different levels, whether you're talking about the manufacturing process, the target market can change, the cost and the risk is evaluated, the price. And so that's usually this iterative process is where you go through the development of new products.
And so when you just trying to develop a new product, something that's not, it's not a product that's existing on the market, it's something that's new to the market. What are the things that you're looking at from an engineering perspective?
Yeah, if we go to the next slide, I think we can illustrate some of the aspects of it. So whenever you're developing a new product, you have some prior knowledge, right? That this is, well, if you're an engineer, you have a degree, you have some experience in the field, you may have a license, there's some prior knowledge you have in your head, and there's some knowledge from experience in the field. We'll talk later about standards and things like that. So that prior knowledge and prior knowledge of products beforehand that may been in existence, but may not satisfy the market. That information helps you determine what you might do in a new product, what the user might use it for. And then as you're going through the process of development, characterizing how it behaves, and then looking at the strategy that you're going to use to design this actual process, you're doing an assessment of the risk at each stage, and everybody does this. You're sort of assessing, you know, what is what are the things that could happen if I choose decision X over decision Y in this product. And so through that process at every level, you're assessing the risk, and there's a very well-known analysis process to do that.
And
And-
Dr.
and so-
Whittington, oh, sorry.
No,
Do
go
you mind
ahead,
if I
Jen.
ask- Do you mind if I ask a question? I was just
Absolutely.
curious, when you talk about risk assessment, are you talking about the risk of safety or injury to the community or that sort of thing, or the risk of, well, maybe this doesn't work as well and doesn't sell as well, kind of business risk, or both?
Yeah, so depending on who you're talking to, which person the engineer is talking to, there's different risks that could be business related, but there's also, as you pointed out, there's risk related to the safety of the product, and that we're going to focus on later in the talk. That's an extremely important aspect that we teach engineers. You have to assess the risk related to the safety of your products, and that is integral into the process of design. And there are constraints. There are mandatory constraints from the government. There's those constraints. There's also constraints from the industry where there are voluntary standards. There's also norms in the industry. And then there's also knowledge that you have prior to the product, things that are foreseeable. And you're absolutely right. You have to have that understanding through every stage as you're making every decision, to the point that you say, okay, well, this is a new product that I'm going to put into the market.
We have a question from the audience that might work right now. If not, if you're going to address it later, then just let us know. But Reed Womble is wondering what the standard of care is in a product's liability case. And is the standard of care different for the manufacturers, distributors, retailers, and whatnot down the line?
Well, so
Yeah.
and let me preface this. We're going to get to some of that stuff in a little bit in the PowerPoint, but really the standard of care when it comes to product liability or product cases is going to be different from each and every state. But generally speaking, the design process, once you identify a hazard, the manufacturer is supposed to do something. Whether or not they have actual notice of a danger of the product or not, the manufacturer is always responsible for it. But each state's laws is different. But there are certain overarching principles within products cases that apply to pretty much universally within every state and within the design community, and we're going to get to that in a little bit.
Awesome, thank you.
Awesome.
Next slide, Ross. Okay, so a risk assessment. It's especially related to safety. That for products liability, I think this is the big focus that needs to be considered from a lot of these cases. And Monte, I'm sure, has seen this time and time again. But identifying the hazards and performing a risk assessment is it's a very important documented process. And so it qualitatively and quantitatively mitigates risk. That's the point of it. But it's also something that you use to document the areas that you are investigating. And that's a very important aspect of identifying risk. We'll have an example of a risk assessment later on, but I want to show you to the right that in these hierarchies, there's two different categories that you have to look at. One is the probability or frequency, depending on which risk assessment you're using. You could say, okay, well, it's very likely or it's unlikely. And then if you're using a frequency domain, you could say frequent or occasional. that determines whether something's going to happen. That's your ranking of whether an incident may even occur. There's another category, which is the severity or the consequence of it. And so you have this other aspect of risk assessment, which says, okay, if it happens, let's rank the result from that. What, a death being worse than an injury to a person may be worse if it hurts more of them, a whole arm being taken off versus a finger. And so those ranks are then ranked as well. And the combination of the probability and the severity gives the rank of the risk for a specific hazard that's identified. And I put references. Go ahead, Monty.
No, so once we establish there's a market for a product or a possible market of a product, and then then in the design process, when engineers determine, we're going to start trying to make this idea an actual thing, to realize the idea in the market as a product, we have to you have to do a risk assessment. In the risk assessment, what it seems like to me you're saying is that you have to evaluate that product, how it's going to be used, how that product's going to be used in the market, and what risk or hazards that can happen from the use of that product.
Absolutely. And there's a ton of standards and references that go through this. So if you've never seen one, or maybe you have one, but you're trying to think, is this the only way to do it? We put some references from ANSI and ISO, and they have a ton of information, including examples, one that we'll show later, of how it's done.
And so when you have this, let's go back real quick, Ross. When you identify the product, how it's going to be used, and you identify the is it okay in the design process to just not do a risk assessment, not list out what are the foreseeable type incidences, whether it be injuries or catastrophic events or anything? Is that okay to just not do a risk assessment in the design process?
Of course not. Yeah, and there's a lot of things that don't happen in business, and so that's where that's why I think of what we do in helping Monty and people like Monty is coming in on the back end and saying, okay, well, what should have happened in this design process? What was missing that led to an incident occurring and or increasing the severity of harm or consequence from that incident? And then backing up and saying, well, was a risk assessment performed? If a risk assessment was performed, was there a hazard that was well known at the time that wasn't included in the risk assessment? And how did that lead to the company developing this product that they did not include that in the design? And so that's very important.
So it would be key anytime you have a products case, or you're considering a products case, is that's going to be one of the first things that you look for as a lawyer prosecuting a products liability case, is the risk assessment that was done, and whether or not that, if it was performed, whether or not it was performed correctly. So and another thing that's important about these risk assessments is when you ask for them is, as we all know, this gives us a listing of all the possible OSIs that could be out there. So this gives a roadmap of like how we get the evidence and what evidence there is to get to prove that whatever happened from the use of that product was foreseeable. And we all know that is the key element that we have to prove in any type of negligence case, but particularly in a products liability case.
How do we, from a practical standpoint, for those of us who maybe have never done a products case or maybe are learning a new way of doing them now, how do you ask for this? Do you straight up put in the discovery request, give us your risk assessment? Or
yes, because sometimes I'm prosecuting a products case right now. They don't call it a risk assessment. So they gave me a batch of, a terabyte of data, over 1 million documents, and there wasn't a single risk assessment in there, but there was a hazard assessment and a hazard analysis, and they'll call it different things, but in the industry, most of them are called risk assessment. And if you ask for a risk assessment or risk analysis in discovery, and they've done it, whether they call it something else or not, they should put it out there. And a lot of times in the user manual, it'll talk about the risk assessment or the risk analysis that they do, and they use that, and they use a scale to provide the type of warnings that they're supposed to provide, or that they do provide. So they usually, when they're talking about the instruction manual and the warnings on labels and stuff like that, a lot of times they'll refer to a risk assessment. And sorry if I'm getting to something that y'all are going to talk about in a minute, but
it's so hard to know. Like, I'm like, should I ask the question? Should I wait? I don't know. It seems like a good spot, but you guys just let me know if you're going to address this later. I do have one question from the audience. And again, if it's something you'll address later, just, say we'll address it. But this Jay Foster is wondering, does the ISO or ANSI apply to home elevator lifts made by a company that is located within just one state? So kind of do those broader international standard. I think that's really the question, is do these larger international standards apply to a state organization, lifts or elevators in a home?
So a state, so if we're talking about the United States, the ANSI applies. There may also be, so that would be a voluntary standard. There may also be required standards. And Ross, towards the end of his presentation, he will kind of give you that roadmap about how to determine that for your application. I think that'll be useful. But just to quickly answer it, and then Ross can get deeper, and you can ask it again if you want to know something else.
Awesome, thank you.
Okay, so yeah, so with a risk assessment or risk analysis, and whatever it's called, you may have the company that has it. If they have it, great, there's something to work on. Sometimes it doesn't exist, but as Monte just mentioned, you may pull it and they say, well, we identified the hazards, but we didn't rank them, or we didn't try to mitigate them. So it's important that it's done in completeness, and that the hazards that are identified are hazards that the engineers should have been aware of. And that's really important in a risk assessment, because even if you see a risk assessment, you have it, you really need someone to look at it who is qualified in the field to say, does this have all the hazards that exist for this type of product, or that was known there? Okay, if there is a hazard, was it ranked properly based on its probability and based on its severity? And then if it was ranked, what was the mitigation strategy? Was it just left alone? Was it ignored? And so just because someone has a risk assessment doesn't mean they have it correctly. Doesn't mean that they had it at every stage. A risk assessment that's had before the product was ever used, and then no risk assessment after new information is found out once it's in the stream of commerce, is also not good. So make sure that you have someone evaluate that. And there's, on this fourth bullet point, Monte, maybe you want to say something about OSIs?
Yeah, so the risk assessment, I mean, that's going to give you a listing of your other similar incidences or your OSIs of the foreseeable ones. In the other, so for your Paul's graph fans out there, I mean, this puts everything that's listed on the risk assessment within that zone of danger, within the things that could foreseeably happen. So they become relevant in every single aspect of your case. And you can use these risk assessments that when they do them, or especially when they don't do them, but you can use those risk assessments to get your OSIs in, because 99% of the time, the stuff that they identify on the risk assessment is stuff that's happened, or stuff that when they tested it or did certain things, they knew it was going to happen. So they had actual knowledge. So, and Dr. Whittington said something very, they have a duty once they identify that stuff, it is to mitigate those risks. And we're going to get to the mitigation aspects in a little bit. But the first thing that I wish I would have done this when I first started prosecuting cases, is the first thing that I do on a products liability case when I get a Ross or Will involved in a case, without giving them the discovery, without giving them stuff that I've gotten from the defendants or that I know about, I say, I want you to take this product and perform your own risk assessment or risk analysis on this product. You do it on the front end without the benefit of hindsight. And that is super enlightening and gives you a roadmap of where to go and what to go look for in your discovery. So if you're lucky enough to get a case and get somebody involved before you even file it and get that risk assessment, even if it's a crude risk assessment, it helps you focus you on what you need to get and what's going to be important in your case to prove foreseeability.
And then is this kind of, we have a question from the audience, Kenneth Bland, is wondering if this risk assessment from a mechanical engineer perspective, is it different from a root cause analysis? It's a good question.
Well, root cause analysis happens after something's happened. A risk assessment is done on the front end. So it is different than a root cause analysis, but you can still apply a risk assessment or a risk analysis to other types of cases. They're not just products liability cases. You can use them in a negligence case. You can use them in a medical malpractice case. You can use them in a premises case. Any kind of case that you can think of, you can use a framework of a risk analysis. And human factors experts and warnings experts, your doctors that did the medical research that know of they know of certain procedures and certain medical devices or whatever that you use, the potential hazards out there, because they've been studied and they've been studied and studied and studied.
And Monty, I'll jump in. A root cause analysis for, let's say, a failure of an engineering product, that actually helps drive hazards that are identified in mitigation strategies for future products. So there may be some of these reports prior to the product that you're looking at that should have driven a risk assessment in the new product. A lot of standards where the metrics come from, whatever the number and the dimension is, come from these studies where things have failed in the past. There was an in-depth study. It determined that under certain scenario, there's likely to be a failure, and then that drives the documentation after. And so, like Monty said, if you're talking about a specific situation and you have that report where it's a failure report, that was done after, of course, the product has failed, but there may be these reports for prior products that are similar that were used to drive the standards, the regulations, and the identification of hazards in the product that you're looking at.
Okay, so even that retrospective analysis kind of that we were just talking about, where Monty says, hey, here's what happened, here's the product, or even just here's the product. What would be your process, or kind of almost a standard of care type? What would be the appropriate process to go through and the hazards to look at and that sort of thing? It's not really a root cause analysis of what happened. It's more, did they do what they were supposed to do? Is that correct?
Yeah. And for the sake of time, let's move on. I've got I think there's a slide here that'll help illustrate that. So this goes through the risk assessment process. Keep going, Ross. Let's. Okay, so here in the example risk assessment, and you let me know if this answers the question. You have these hazards. If you look at the second column down, you have all these hazards based on how this device, in this example, a woodworking mill. You have these users that are going to do certain actions. These actions have these identified hazards that are coming from prior knowledge in the field, from similar products. Maybe there's another woodworking mill that a different company made. Maybe there's another woodworking product, a saw that has similar physics. And then also the engineer who has in that person's mind the physics related to it. They're pulling in these hazards based on that information. So you're using prior knowledge to do that as you develop these hazards. And then once you develop these hazards, you say, okay, well, you might get splinters. And then you look at the initial assessment. You can develop a prototype and run some initial tests. And you could say, well, what is the probability that may happen? Well, it might happen sometimes. It may not happen all the time, but it might happen sometimes. And what is the risk level based on the injury? So here they picked medium, because if you compare that to noise down there near the bottom, where you could, for instance, lose your hearing, having a splinter in your finger is not as severe and not as likely as the noise. If you're there and you have the noise, it's going to happen, and you might get a splinter. And then after you get that initial assessment, you then say, okay, well, what can we do to mitigate this risk? In the case of splinters, for instance, you could require gloves. So you're putting a label saying that you need to have gloves whenever you operate it. It's going in the manual. You're making sure that any user that's doing this action is wearing gloves whenever they do that. Then you say, okay, well, let's redo the risk assessment and see how this mitigation strategy affected the risk. So now it's the severity is less, because even if a piece of wood gets stuck on you, it's stuck in the glove. It's not stuck in your finger. It's not hurting. So now the risk level is negligible, and you can then track. Some risk assessments will have a status as they're working on it, and so you can see whenever the report was generated, whether those engineers felt like they have done their best job in that category. And so this is an example, and there's a lot of examples out there from the links or the references that we provided. And so you can look at those examples as well if you'd like to see them for different machines and different products. Go to the next slide, Ross. So whenever you're mitigating these risks, you can eliminate them, of course, in the design. If you have the knowledge, the capacity, if the technology exists, you could choose different types of product design strategies to change what components exist in that product. Also, if there is some hazard, let's say it's a motor behind that's spinning really fast and you're worried about the risk of someone getting caught in there or getting injured by it, guarding is there. And OSHA has an entire category for machine guarding, and guarding is very well known. And looking at which standard your drives that field will, there's a lot of regulations against guarding, and then also warning. So the labeling that you have there that says, okay, don't do X or don't do Y, or wear proper protection, wearing earplugs, right? That also is another way to mitigate risk. Go to the next slide, Ross.
Real quick, before we go to the next slide. So somebody asked about the standard of care, and this, generally speaking, is the standard of care of a manufacturer when they design, manufacture, and sell a product. And this is taken directly from the hazard control hierarchy or the safety design hierarchy, whatever the engineers call it. It's kind of an evolving name, but it goes, the first layer of it, you're supposed to try to eliminate the danger by design. The second layer of it, you got to guard against the danger or the hazard. And the third layer, warn against the hazard. Now, they continue to add stuff, but throughout, I know the Mississippi Products Liability Statute, they specifically have these three categories in which you can prosecute your product's liability claim. Most other states do. Some still go by the old strict liability. If somebody's injured by a product, it's strict liability. All you got to do is prove that they were injured by the product and the manufacturer is liable. Other states are more stringent, like Mississippi, where these are the only three ways really where you can recover against a manufacturer. You got to prove that there was a design alternative and they could have eliminated that hazard by design, or guarded against that hazard, or they should have warned or instructed on how to avoid that hazard. So that's, generally speaking, the standard of care really for most product liability cases.
Right. And so, and I think this kind of directly answers the question earlier of, where do you get this information? How does this information inputted in the process? And to the left, you sort of see that, okay, this box is where the engineers are doing the design. And there's some need that's being fed in either by a different department or directly by a customer, depending on how the business is structured. And then to the right is the resulting solutions, what the array of products that could be realized. And what's being fed into to the engineering that's happening is two parts. One part is this domain knowledge that the engineer has. This is the physics, the material science, the background. This is what qualifies the engineer to have that competency that is necessary to make decisions. So one issue sometimes in products is the person designing the product was not qualified to design that product because that person did not understand the physics that governed it. There was a comment about an elevator earlier. So if the person doesn't understand forces and loads or strength of materials, if they don't have a background in mechanical engineering, even if they understand, okay, well, there's a need for an elevator and I need to try to make an elevator for a building or whatever. Even if they pull in standards, they're not going to know how to apply the physics to make the right selection of components. So part of the information that goes in is from the expertise of the engineer or engineers that are designing the product. Another part is the knowledge of the design process, and that's all of the information that comes in from the field. And this could be constraints in manufacturing, constraints in the retail, the use, the end of life. If you look to the right, this is an example of the factors that constrain the life of a product. And so there's a lot of different categories in the product development where you're identifying a need, planning for the process, and to the point that you develop a product. But once you develop a product, that's not everything, right? Then there's got to be manufactured, assembled, distributed, and installed, and then someone's using it. And then whenever it's used, it may have maintenance that has to be done for that product to operate. In some cases, and now we're seeing this more and more, the end of the life of the product is also important. It's very important in the nuclear industry, important in waste, and now becoming more important in plastics and in fields where there are some effects based off of the disposal of it. And so in all of those areas, there's information that has been documented through standards, regulations, de facto norms that has to be pulled in. And so the combination of pulling in all of that information plus the expertise of the engineers that do it, that's what gives all of that information that allows for the hazards to be properly identified, properly ranked, and mitigated to the best of our ability at this point. Go to the next slide, Ross. And so I'll turn it over to Ross here. Ross is going to talk about standards specifically, but I want to leave you with the standards have a hierarchy. And so there is regulations that are required, either imposed on a federal level or state or local level that have to be abided by. There's no wiggle room. It has to be done. But then there's also standards that are voluntary. And in these standards, there's, if you look at the pyramid to the right, there's general safety requirements that are just, they're blanket for everything. Any kind of machine, any kind of device that's being made. And then from that, inside of that category are these reports, these technical reports that are for that field. So, if we're talking about general safety requirements for toys or things that people play with, then we can talk about technical reports on trampolines in general. And then we can talk about a machine specific for a specific type of trampoline in the case of Monte. And in all of those categories, the important thing that I want to bring your attention is the statement to the left from ANSI that is in the general safety requirements that governs all of it. The use for which machine is suited according to the information provided by the supplier, or which is deemed usual according to its design, construction, and function. So that's the intended use. So basically all of the information that is provided to the designer and is known by both what the designer is aware of in their own mind because they're competent and qualified, and also from the field. The intended use involves compliance with the supplier's instructions, which should take into account reasonably foreseeable misuse. The intended use may be determined by the user. And so there's also this burden on an engineer to say, okay, I may expect people to use it this way, but I have knowledge that people may not. And having that knowledge that it may not be used in the way that you intend provides a burden on the engineer to mitigate those as well. And that's a critical piece of information that we teach on the front end at Mississippi State to the engineers. And then that's also a part on the back end that Monte has to deal with products that didn't consider that. And so there's a lot of examples. In the case of the trampoline, a kid was told not to jump over something or go under another rod, but it's a kid, having fun. So you may tell the kid, don't jump over this, but you need to expect that children are going to do it if it's if it's fun and if you have evidence that they've been doing it. And so understanding that what's foreseeable is the use, but you also need to foresee how people might misuse the product, because many similar products have been developed prior to this. And if you have an understanding in machine design, you understand that things could happen. And so go ahead, Monty.
Yeah, so what I was just going to ask you, the two, like if you've handled a product liability case, you know for a fact what the two major defenses are going to be from the manufacturer. And the first one's going to be they misused the product. It wasn't supposed to be used by that way. Well, and is that legitimate defense?
No, so it's not, because from an engineer, engineers have a responsibility to use the engineering field to improve the quality of life. And if you're aware that people misuse a product in some way, then you're aware that this is a risk for your product. And so you have a duty to mitigate that. You can't sit by and say, well, I knew everybody was going to do that anyway, but that's not what I would have used it for. That's not why I designed it. So if there's a lot of injury and pain and suffering, that's on them. That's not how that works in engineering. That's not what we do. And so go ahead.
The second defense that is, I mean, if I've heard it once, I've heard it a million times, is, oh, those standards, those things were voluntary. We didn't have to comply with those. So in every single expert, in every single case I've ever had, I get a whole lot of questions from the defense lawyer saying, well, these standards, the ASTM standards, those are voluntary. We don't have to comply with those, do we? Is that a legitimate defense?
It's usually not. And the reason is because standards are there to make it easy for an engineer to find the information. The question was asked earlier, well, where do you find that information? So if someone's saying, I don't have to comply with a standard, so I don't even open up the standard to find out that if this component's too hard or moves too fast, it could injure somebody. That's not engineering, right? The only reason standards are voluntary to this point is because there is new products that come out that change what the use are so deviant that there may be a reason, but it's got to be a very strong reason. It can't be, I didn't do this standard because I just didn't want to, or because I liked my product. I felt like it was a lot better. It has to be, this standard has a regulation that was intended for a different use, for a different feature that I'm trying to promote here. And that's the important thing. These standards, people spend a lot of time putting these together. Most engineers that work on these boards work at companies around the country. They don't get paid to do this. And this is a service that they do to tell other engineers how to design the products. And so if an engineer is saying, I don't have to do it, so I'm not going to do it, that's foolish.
Well, I think that leads us into kind of our next section, right? And so just kind of introduce myself before I get started. So I'm Ross Smith, also with Dr. Whittington from Mississippi State University. And really today I wanted to talk about what is a standard, right? I know that this is used a lot in product liability cases, and not only for expert lawyers like Monty is, but I also feel like the audience is going to be some young lawyers just now getting to the field of product liability. With that, I felt like it's really good not only to know that there are standards out there, but I thought, having a quick discussion and kind of taking a deep dive into what is standards, some different examples, what are the different entities or organizations that create these standards, and what's exactly the process flow and how do I find these standards and how do I execute them. So first, I think we should start out with, what is a standard? So a standard is essentially a pre-described set of rules or conditions or requirements concerning definitions or terms, classifications of components, and they also do the specifications of the different materials, the products, the systems, or service, or even practices, right? And so even us, a condensed sentence, right, on this slide, it covers, right, a wide range and overview of the standards. And for us, our entire life are dictated by standards, and we don't even know it, and they're everywhere around us. And they play an essential role in our lives. And if you know the knowledge of standards, I think it's going to help you think about your cases differently. I think one, for example, is, let's talk about, there's standards for product and design-based standards, right? The base on your electric lamp has a standard associated with it, right? There's performance-based standards, right? So our functionality and capabilities for all your appliances in your house, your refrigerator, right, has a certain cooling load standard, your washing machine. We also have things like process-based standards. So in terms of like manufacturing, you have the welding, you have process standards regarding welding and the correct way to do that, as well as testing and measurement standards that's associated with products and devices associated with them. So standards kind of set the size, the shape, the capacity of many different products and processes or systems. They also lay out the performance duties for all these products or processes or systems. So a standard also defines what I would like to call, or what the interpretation of the standard is, clear for all to use, right? So the way these standards are created is in a way that makes it easy, no matter if you're an engineer or a lawyer or just someone off the street, they're able to take these standards, and it's clear and concise to understand an overview, so you can check, right? And so you can also see it from a consumer standpoint, is this product safe? At the same time, standards are key because they essentially provide a way for consumers to help evaluate their products. Standards also allow companies, right, to ensure that they have the highest quality of goods and products that they can put out to the marketplace. But most importantly, standards are there so they can ensure the safety of their consumers and their products.
So let me ask you this. Are standards, are they basically just safety rules?
Well, I wouldn't just say just safety rules. It's a lot in between, right? So when it comes to standards, they have specific design components, the instructions, and regarding the manufacturing process. But I would say it overall ties back to the overall safety of the consumer. When you look at a standard, those are, and I'm gonna get to that here in a minute, standards are pretty much created from large committees and subcommittees that come together from expertise all around within that industry of where that product's designed. And their whole goal in mind is to create these standards to ensure an overall level understanding and consensus within that field of that product. To say, hey, this is the correct way based off the knowledge that we have gotten over the years and the expertise that we have to ensure that we're designing a safe product for the consumer. So one of the things I want to talk about is mandatory standards. And I think Monte kind of hit on that with a question earlier on the different types of standards. So first one up is called mandatory standards. So these are set by government agencies. So your FDA, every time you go to your supermarket, right? Those different type of standards are in place from the FDA to ensure that you don't get sick at night, right, after picking up a steak. Also, there's OSHA standards, right? That's very widely known across the United States, typically in manufacturing and construction settings. Secondary is what we call voluntary standards. And this is what we kind of touched on a little bit earlier, but they are essentially established by consensus, which is usually made up of different partners within industry, custodians, stakeholders, and they're typically developed by what is traditionally called SDOs, or standard development organizations. And I know I'm gonna hit on that here in a few minutes, because voluntary standards is where you're traditionally going to see, right, the majority of the standards that are out there in the world today that is fall within industry. But I would like to kind of pinpoint the word voluntary, right, for these standards. Does that mean you don't have to follow them, right? It only refers to the process of their creation and implementation, okay? And I'll kind of touch on that a little bit on the next slide. So the other thing we'd like to talk about is de facto standards. I think Dr. Whittington touched on that a little bit earlier, but essentially what is a de facto standard is based on common, well-established practices that are not developed by formal SDO, right? And so a great example of this is what I like to call for the arrangement of keys on a keyboard, right? And so there isn't a standard in place. If you look at the top left corner of your keyboard, right, the letters are going to be QWERTY, right? This isn't a standard that is officially published by an SDO or a federal government organization, but yet, right, we follow it traditionally because that is the standard across the marketplace. If you come out with a new product with the keys all rearranged, right, it might not do very well in the marketplace that's already well established with a traditional use of this standard, okay? And so one of the other things I want to talk about this is I'm hitting you with mandatory standards, voluntary, and there's a lot of them, okay? So I would talk about just voluntary standards alone. In the US today, there's over 30,000 voluntary standards, okay? So it can get really overwhelming, right? And they can say, man, where do I even start? I got this new case, I'm looking at this product. How can I even wrap my head around where to go first to really understand? There's so much information out there. And one of the first things I want to kind of help showcase that is when you have to go look at the standard developed organizations and also the accreditors, right? So there's several organizations that play a key role in the development and the promotion of standards in the US and internationally. So one of the big ones, right, is ANSI. So ANSI is a nonprofit. It is a non-government private sector membership organization. And it is the central focal point of voluntary standards being developed here within the United States. So ANSI traditionally, facilitates the development of what is called the American National Standards, which is ANS, by accrediting the procedures of standards and also accrediting the development of organizations or SDOs. So ANSI typically works with a group of collaborative, volunteer national consensus standards, and they're essentially the only organization within the United States that is approved or represents the United States in terms of standards creation globally. So if you look at ANSI, the only other two major partners on an international scale when it comes to standard organizations will be ISO, which I believe there was a question or a mention about that earlier in the segment, as well as the IEC, which is the International Electronic Technical Commission. Just kind of a statistic here, so the United States has around 237 ANSI accredited SDOs currently. So, and when it comes to SDOs, right? So SDOs may choose, right? So SDOs may choose to help develop these type of standards with ANSI. But I think it's really key to say, right? And I'll kind of re-mention this topic, is ANSI's entire focal point is to help develop voluntary standards within the U.S. consumer market. Let's see what we got here. So let's talk about SDOs. So for SDOs, oh, it switched on us there. So for SDOs, they're essentially the standard development organizations. They include, like we mentioned, professional societies, different members from industry, trade association, other membership organizations, and they essentially all come together to help and assist their expertise to help develop these voluntary standards. And some of the major SDOs that you're going to see or you'll know in product liability cases is ASTM. You're going to have IEE, SAE, and ASME, which is like the American Society of Mechanical Engineers. And I also wanted to kind of showcase that because there is so many standards out there, And there's so many different organizations that I want to include a link to at least help you arrive or to get at least a starting point resource in terms of your research, determining which SDOs are operating in your area. And you can always look at it. I have this link attached for the ANSI website that has the 237 accredited SDOs throughout the United States. So one of the other key statistics I want to go before we go to the next slide is actually out of the 20 largest SDOs in the United States, they are responsible for over 90% of the voluntary standards. So kind of wrapping it up here in terms of the standards section is when you look at, ASTM, they're one of the largest. And so they have over 12,500 plus standards for products and equipment. And when it comes to research and develop these standards, you really have to go in and dig deep into each different organization and look at the standards and even go back, right, years and years to possibly when your case occurred. So because of this, and all these numbers I'm throwing at you on the amount of quantity of standards that are out there, your expert witness should also know that there is a backlog of relevant standards over years and years, because we learn and we grow as engineers, we come back to help mitigate and solve the problem. And part of that role is to come together and correct and reestablish new standards when hazards or problems are identified. So Monte, do you want to kind of touch on a couple of these slides related to the case?
Yeah, so you got to also remember these standards, the ASTM standards, they're written by the industry that you're suing. The people that are on the committees and the subcommittees that are writing these standards are written by the industry insiders. So you got to be very careful and look very carefully at who's sitting on the subcommittees that is writing it and what products they have in development or when they have them developed. So you need to see when your product was manufactured compared to when the standard was written, and you can subpoena from ASTM and the CSPC the committee meeting notes, the committee agendas, the emails from the committee members, and all that kind of stuff. So a lot of that stuff will be very insightful. In some of these standards, they have written into them requirements for the manufacturers and the owners of certain things to keep a list of injuries. And that when in certain industries, if they build, in this instance, trampolines, the standard for the trampoline parks is the people that manufacture the trampolines that go in the trampoline parks. The owners of that buy it from the manufacturers, they've got to notify the manufacturers when an incident happens or when somebody's injured on this product. And likewise, the manufacturer, if he finds out about that stuff, he's supposed to notify the people that he sold the product to of the injuries. So there should be records in some of these that are required by the standards. And they'll always, every single manufacturer is going to advertise that they comply, or this product complies with whatever standard that applies. There's different certification places out there, like the Juvenile Product Manufacturers Association. That place takes the standard and takes the product and make sure that the product complies with the standard. And they certify the product, and these manufacturers advertise that it's JMPA certified, or what. I mean, that's just an example. But well, if it complies with the standard in this specific instance, well, they should be keeping data on injuries. You got your OSI, you got your risk assessments and all that kind of stuff. It's a way to find out what should be there from the manufacturers, and when they don't produce it, to call BS and attach that stuff to a motion to compel when you're trying to get this evidence and say, Judge, They say they comply with the standards. The standards require that they keep a list of this stuff and that they notify the owners of the injuries. So you need to get those notices and stuff too. So that, and I think that's a good place to kind of wrap this up.
I was just wondering if, do you guys ever hear from jurors or focus groups or anything that there's too many standards? How is it possible for somebody to comply with all of this stuff and maybe even give a pass, because you're like, wow, they couldn't have possibly been able to do this with 30,000, 12,000, all these standards, I'm just like, oh, these poor companies.
Yeah, I think Monte and y'all have your job cut out for you. However, in engineering, we focus.
Mm-hmm.
And so in an industry that you're there, people spend their entire lives working on elevators. Mm-hmm. They spend their entire lives working on lawnmowers. Their entire lives working on trampolines. And these standards are written by them for their industry. And so when you actually connect with an expert in that field, you'll find that the world's very small for that product.
Okay.
So yes, like Ross said, it's overwhelming if you're outside of the field. But we find the world smaller every day in the work that we do. And so
I'm not expected to know 100,000 regulations as I sit here designing my product. There might be 13 that apply to me, or
exactly. That's why I say the engineer, that slide where the engineer needs to have something in their mind from that field. If the engineer is not qualified there, then there's no way for them to know. If they're designing an elevator and don't know what gravity is, you can look through standards all day long, but you don't know how to apply the basic physics or the practices for that type of product. And so that's what brings in the knowledge from the qualified individuals. And that's, I keep saying that the qualified individuals, because you can't, even if you hear of Elon Musk on the internet designing a car, there are real qualified people behind the scenes that you haven't met who were designing vehicles 30 years before Tesla was even a company, right? And they just moved from one company to another company, but they brought with them all of that knowledge. And so all of that information goes in. New products in the engineering realm make very small and steady incremental improvements. If you drive over a bridge that was designed yesterday, you drive over a bridge that was designed 100 years ago, you'll see some slight differences. It takes a long time for products to change. And the reason is because there's so much risk when you introduce a new product, and there's just so much. It takes a very long time to do that. And so it does seem big, but engineers focus.
And then along the same lines, I know we're over time, so thank you for the live audience who's hanging in there with us. But along those same lines, have you ever, I guess, in your experience, Dr. Whittington or Professor Smith, or I guess Monte as well, seen a true situation where the manner in which a plaintiff was using a product really was unforeseeable? Like, I don't know, wearing your shoes on your hands, or driving, I don't know, wearing a furry suit that, I don't know, something strange.
It's possible. It's possible. And that's why I had that slide where it showed the life cycle of the product, where when it gets into the user's arms, there are things that happen that make you aware of new hazards, which as an engineer, it's time to include that new hazard to assess what that risk is and to mitigate that. And so you're not done whenever you put a product into the stream of commerce. You're just you're putting it out there because you have taken in all of the information up to that point to the best of your abilities, and you try to make this as safe as you can, and then the product is out there, and then whenever there's new information, that's how we get version 1, version 2. That's how cars changed. They didn't have seat belts at one point in time. Well, they got faster. The cars got faster. Now they have seat belts and even airbags. And so, no, you're not done whenever the product gets out there.
All right. All right.
No, I think that's really good to state too, is because there's constantly revisions being made, and then there's also constantly standards being redacted, right, for being too unsafe, right,
Okay.
and taken away, and having to come back to the drawing board again, these organizations, to create new standards, right, to replace them. So it's a constant, ever evolving kind of industry or sector when it comes to these standards.
Awesome. All right. Is that what we've got for today? We've gone a little bit over. Sorry, everyone, but this is really interesting. Thank you so much, you guys. This has been great. If we're kind of wrapped up, go ahead and stop screen share. All right. Awesome. Thank you so much to all of you who joined us for this week's episode of Fridays with Keenan's Cutting Edge. Thank you for hanging in here with us for an extra few minutes of super interesting, and I hope very helpful and practical information that you can take from this and bring straight to your cases. If you're in the discovery process on a product liability case, I hope you learned a ton today about what to ask for, what to talk to your experts about, and possibly where to find experts. We talk a lot about what experts are kind of out there, but look, we just at your local university, you can find folks who are passionate about this topic and others as well. If you like today's episode, please click that thumbs up to feed the YouTube algorithm, and don't forget to subscribe and sign up for alerts so you don't miss an episode. Next week, we have Lucas Faust with us talking about institutional plaintiffs. Now, Monty tried to help me understand what an institutional plaintiff is and what that topic entails, and maybe some of you already know exactly what I'm talking about when I say institutional plaintiff. But all I have to say is I'm going to have to tune in next week to find out what an institutional plaintiff is and why I even need to know about them. So as always, I look forward to learning about that topic along with all of you. Have a wonderful weekend, and I'll see you next time.